Hello students, in the previous lecture I was discussing about real time about the basic functions of real time operating system kernel, or you can say real time kernel. And there I was discussing about memory management. I told that real time operating system makes use of block based memory allocation technique, and it uses blocks of fixed size of dynamic memory, and the block is allocated for task on a need basis. Now next I'll be discussing about the interrupt handling. So interrupt handling, so it here the real time operating system deals with handling of various types of interrupts, and then the last is time management. So accurate time management is essential for providing precise time reference for all applications, and the time reference to kernel is provided by high resolution real time clock hardware chip. So next, moving on to this wait okay this real time operating system, it is divided into two more parts, that is hard real time and soft real time. So what is hard real time? The real time operating system that strictly adhere to the timing constraint for a task is referred to as hard real time systems. So a hard real time system must meet the deadlines for a task without any slippage. And the second one is that is one is hard real time, and the second one is soft real time. So the soft real time operating system, that it does not guarantee meeting deadlines but offer the best effort to meet the deadline. Now moving on to the process. So basically a program or part of the program which is in execution is called a process, and the terms task, job and process, they all refer to the same entity in the operating system. So this is the structure of a process, and this structure, this process, as I've told you, it's a program or part of the program which is in execution. So this is the structure of the process, as you can see. So a process mimics a processor in properties and holds a set of registers, process status, a program counter to point to the next executable instruction of the process, a stack for holding the local variables associated with the process, and the code corresponding to the process. Next, coming to what is thread. So a thread is a single sequential flow of control within a process. So a process or task in embedded applications may be complex or lengthy one, and it may contain various sub operations. So if all the sub functions of a task are executed in sequence, the CPU utilization may not be efficient. For example, if the process is waiting for user input, the CPU enters the wait state for the event, and the process execution also enters the wait state. So instead of this single sequential execution of the whole process, if the task or process is split into different threads carrying out different sub functionalities of the process, the CPU can be effectively utilized. So this is what we call multi-threading. So the advantages of multi-threading are better memory utilization. This multi-threading speeds up the execution of the process, and efficient CPU utilization, that is the CPU is engaged all the time. So next I'll discuss the concept of multi-processing and multitasking. So what is multiprocessing? In the operating system, the multiprocessing, it describes the ability to execute multiple processes simultaneously. Systems which are capable of performing multiprocessing are known as multiprocessor systems, and multiprocessor systems possess multiple CPUs and can execute multiple processes simultaneously. Whereas multiprogramming, it is the ability of the operating system to have multiple programs in memory which are ready for execution. So this multitasking it can be of various types. Like the various types of multitasking existing in the operating system are cooperative multitasking, preemptive multitasking, and non-preemptive multitasking. So cooperative multitasking is the most primitive form of multitasking, in which a task or process gets a chance to execute only when the currently executing task or process voluntarily relinquishes the CPU. Preemptive multitasking, it ensures that every task or process gets a chance to execute, and as the name indicates, in preemptive multitasking, the currently running task or process is preempted to give a chance to other tasks or process to execute. Non-preemptive multitasking, in non-preemptive multitasking, the process or task which is currently given the CPU time is allowed to execute until it terminates or enters the blocked or wait state, waiting for an input output or system resource. So in cooperative multitasking, the currently executing process or task need not relinquish the CPU when it enters the blocked or wait state, but waiting for an input output or a shared resource access or an event to occur. Whereas in non-preemptive multitasking, the currently executing task relinquishes the CPU when it waits for an input output or system resource or an event to occur. Moving ahead to the next is task scheduling. So multitasking involves the execution switching among the different tasks, determining which task or process is to be executed at a given point of time is known as task or process scheduling. So the kernel service which implements the scheduling algorithm is known as scheduler, and the process scheduling decision may take place when a process switches its state to ready state from running state, blocked wait state from running state, ready state from blocked wait state, and completed state. Now the selection of a scheduling criteria or algorithm should consider the following factors. They are like CPU utilization, then second is throughput, third is turnaround time, fourth is waiting time, and the fifth is response time. So this was all about this topic. I'm ending this class here. Thank you.